So look at momentum, laws of motion, projectile and angular motion past paper questions. The first question we have here: 50 kg skater traveling at 4.5 meters per second collides with a 65 kg skater traveling at 2.5 meters per second in the same direction. So here you have got one person who is going in this direction sliding, and this person is 50 kg, okay, traveling at 4.5 meters per second, and then gets to encounter another person who is traveling also in the same direction, but the mass is 65 kg at 2.5 meters per second. Now the question is, if the two skaters remain in contact, what is their final velocity? In other words, they get to stick. So using the conservation of momentum, m1 u1 plus m2 u2 is going to be equal to, since these get to stick, they're going to have the same combined velocity, so just get to add their masses and then they'll move at the same final velocity. So let me call this as m1 and this as m2. So therefore m1 is 50 kg moving at 4.5, m2 is 65 moving at 2.5, and that will be equal to, we just get to add the masses, 50 plus 65. So I want to find now the final velocity. So let's just get to punch that on our calculators. 50 multiplied by 4.5 plus 65 multiplied by 2.5 should be able to get 387.5, and that is going to be equal to 50 plus 65 gives us 115 V. So to be able to find V, we just get to divide 387.5 by 115. So that is going to give us 3.37 meters per second. So that is the velocity at which they travel. And then how much kinetic energy is lost? So to be able to find the loss in kinetic energy, you should be able first to find the initial kinetic energies of these two. So the initial kinetic energy is going to be equal to the final kinetic energy plus the loss. That is because energy is always conserved. So if there are some losses, then when you get to add those losses to the final kinetic energy, you should be able to find the same value that you had initially. And the initial kinetic energy is half m1 v squared plus half m2 v squared, and that is going to be equal to, at the end they were moving at the same velocity, so they are going to have also a combined kinetic energy plus the loss. So this will be half the mass for one, that is 50, and the first skater is moving at 4.5 meters per second, so we get to square that, then plus half the second skater has got a mass of 65 moving at 2.5 meters per second, we get to square that, and that will be equal to half the combined mass at the end is 115, and then the velocity at which they are moving is 3.3637. We get to square that and then plus the loss. So let's work this out. So we have got half multiplied by 50, okay, then multiplied by 4.5 squared, and then we add another half multiplied by 65 multiplied by 2.5 squared. That is going to give us 709.375, and this should be equal to, we go the other side, half multiplied by 115 and then multiplied by 3.37 squared. That will give us 653.02 plus the loss. So to be able to find the loss, we're going to take 653 the other side. So loss is going to be equal to 709.375 minus 653.02. and that is going to give us 56.35. This is energy that is going to be in joules, and the reason as to why this value is positive is because they were moving in the same direction. So instead of there being a loss in kinetic energy, there will be a gain in kinetic energy. Otherwise the value would have been positive. The initial should have been smaller than the final, but the initial is bigger than the final, meaning there is a gain in kinetic energy instead of loss in kinetic energy. A helicopter is climbing vertically at 8 meters per second when it drops a pump near a leaking boat. The pump reaches the water 4 seconds afterward. How high was the helicopter from the water when the pump was dropped? So we've been told the helicopter is climbing up. Let's say this is a helicopter which is climbing up, and it is climbing up at 8 meters per second. So when it drops a pump near a leaking boat, the pump reaches the water 4 seconds afterward. How high was the helicopter from the water? So upon dropping something, remember the helicopter is going up and it gets to drop something going down, which reaches 4 seconds later. So from this information we know that the very thing that it gets to drop, which it gets to release, is going to have the same velocity at which it is moving, except the helicopter is moving. So let's take motion up as negative because it's going against gravity. So the helicopter is going to be moving at negative 8 meters per second, but the thing that it gets to drop will be moving at positive 8 meters per second, the same velocity but in opposite directions. And then we've been given the time at which it's going to hit the ground. So we can say height is equal to ut plus half gt squared. So the height is going to be equal to u, that is the initial speed of the stone, that is 8, and then time at which it's going to hit the ground, that is 4, and then plus half. Since motion is going down, g is also going to be positive, positive 9.8, and then time still 4, we get to square that. 8 multiplied by 4, that is going to give us a 32, plus half multiplied by 9.8, that is 4.9, then multiplied by 4 squared, which is going to be 78.4. So we get to add those two, 78.4 plus 32, that is going to give us 110.4 meters. So that is the height of the fall here. Alright, so just on the previous question, just want to clarify with the statement. Well, the initial kinetic energy here was small, the final was big. The final kinetic energy is small, meaning there is a loss. There is a loss. If I wanted to calculate this loss to have a negative sign instead, to show loss, would have said loss is equal to final minus initial. We can see the final is smaller than the initial, so that would have given us a negative. If there was a gain, this answer would have been negative using this formula we've used here. So just that clarity. A road has a curve of radius 40 meters and is banked at an angle theta that is such that friction is not necessary for a car to stay on the road. If a 2500 kg car is traveling at a speed of 25 meters per second, find the angle theta. We can just know the formula if we want, or we can get to derive it. So here we have a road that is banked, and we have got a car that is traveling on the same road. So let's get to consider the forces acting on the car. We have got the weight force, which is mg. We have got the normal force there, which is making 90 degrees to the surface. We can extend the weight force to have components. I mean the normal force to have components. Okay, I've just drawn this line, is just the line which is extended from the normal force, but let me just get to remove it. Let's break the normal force into components. It's going to have the y component going up, and also the x component like that. So if I get to extend this line of the normal force straight like that, this angle we're going to form here is going to be equal to the angle of the incline, and from our mathematics we know that two lines which are crossing, the angles are the same. So even this angle here is going to be theta. So now we can break the normal force in two components. We can see that the y component is adjacent to the angle, so that is going to be normal force cos theta. The x component then is going to be normal force sin theta. So from here, the forces in the y should balance themselves. The normal force cos theta, which is going up in the y, should be equal to mg, which is going down. And then let's consider now in the x. This force directed in that direction should be equal to the centripetal force, because remember this car has to negotiate a curve. So the centripetal force, which is given by mv squared over r, should be equal to normal force sin theta. So I'll divide normal force sin theta by normal force cos theta. And then also these, we are going to divide them. mv squared over r, we divide it by mg. And of course we can also say this is a times, and then the mg is going to be down. So from here, this will cancel with this, the m also cancels with that. Sin over cos, that is going to give us tan. So tan theta is going to be equal to v squared over rg. So this is the formula that we can just get to know when we are working with road banking. So I want to find the angle theta. So tan theta is going to be the velocity here is 25, and it should be in SI units, meters per second. The radius is 40 meters, and then g, that is 9.8. So tan theta is going to be 25 squared divided by 40 multiplied by 9.8. That is going to be 1.594. So to be able to find theta, we're going to take tan inverse of that value. And that is going to give us 57.9 degrees. So that is the angle at which the road is going to be banked. A 1 kg ball with A has a velocity of 4 meters per second along the positive x-axis. So here is A moving in that direction along the positive x-axis with a mass of 1 kg, and it is moving at 4 meters per second. It strikes a second ball with a mass of 3 kg and initially at rest. So a second ball B with a mass of 3 kg, which is at rest. The collision is a glancing one, that ball A is deflected through an angle of 50 degrees above. So here we are. So this one gets to reflect up. This is ball A at an angle of 50 degrees above the x-axis. Okay, that is above the original direction of motion, and the velocity at which it moves is 2 meters per second. So what is the speed of ball B after the collision? What is going to be the speed of ball B? Well, this other ball is going to be deflected in the opposite direction like that at a certain angle theta. So what will be the speed then? So what we are going to do is we are going to break this motion into the y component and also in the x component. So say in the x first, m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So mass 1, that is 1 kg, it is moving at which velocity in the x? At 4 meters per second. And then mass 2 is at rest, so there's no momentum. And that is going to be equal to mass 1. Now we are getting the components only in the x. Remember, it was deflected at an angle. So we're just getting the component going in this direction. And we also have the y like that. So we can see that the angle is adjacent to the x. So we're going to use cos to get that component. So that is going to be, the velocity in the x is going to be velocity cos theta. And the velocity in the y is going to be velocity sin theta. Okay. So the mass is still 1, but the velocity v1 we're going to use here is velocity in the x. That is going to be 2 cos the angle at which it was deflected, that is 50. And then plus mass 2, that is 3 kg. We don't know the velocity at which you to move. Let me call it vx, that is velocity in the x. That is an x component. So this is going to be 4 being equal to 2 cos 50. That will give us 1.2855, and then plus 3 vx. If I take the 1.2 the other side, it will be 4 minus 1.2. That is going to give us 2.714. That will be equal to 3 vx. To find vx, we divide both sides by 3. And that will give us 0.9048 meters per second. You can just get to put it here. We can now go and work in the y. Also, we find the y component of the velocity of b. So same momentum is conserved. m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So m1 here, now this wasn't moving in the y direction, neither was b moving. So in the y direction, the initial momentum's 0. So that will be equal to, now in the y, we can see that in the y, this one is opposite to the angle. So that is going to be 2 sin 50. Okay. 2 is the mass, or 2 is the velocity. Now I've forgotten the mass. The mass is 1 kg. And then plus m2, that is 3. Now we can see that for m2, it is deflected in where? In the opposite direction. So we're going to, in the y, in the x, they're all going in the same direction, forward. But in the y, one is going up, one is going down. So for this one, I'm going to attach a negative on vy because it's going in the negative y direction. So this will be 0 is equal to 2 sin 50, which is 1.532, and then minus 3 vy. I'll take the 3 vy the other side. So just divide by a 3, and that is going to give us 0.510696 meters per second. So these are the components of this velocity. Now we need to find the velocity itself. So velocity is equal to vx squared plus vy squared, and then we square root that. So vx, that is 0.9048 squared, vy 0.510696 squared, and then square root. So that is going to give us 1.04 meters per second. So that is the velocity at which the second ball is going to be moving. Now the second question is asking what is the direction of motion of Bobby after collision. To be able to find the direction of motion, that is simply the angle when they're asking about direction, and tan theta is given by y component over x component. So theta is going to be tan inverse of y component, which is 0.51069, and then divided by x component, which is 0.9048. Zero point 51069 divided by 0.9048. Then we get the inverse tan. So that is going to give us theta being equal to 9.85 degrees. So that is going to be it for this one. A jet plane is flying in a horizontal direction. So here we have a plane. Okay, which is moving in the horizontal direction at 600 kilometers per hour, and its height from the very down is 1960 meters. So when it is vertically above a point A on the ground, a package drops from it. So let's say point A is here, so it is above point A, so it gets to release a parcel. So that parcel is going to drop. Okay, it drops like that. Now the question is, the package hits the ground at point B. Calculate the distance AB. So what we want to calculate is this distance here. Well, how do we calculate that? The first thing is I want to convert this to SI units, 600 kilometers per hour. So we're going to multiply. We've got a kilometer on top, we're going to put a kilometer down and then a meter on top. We know that in 1 kilometer we've got 1,000 meters, and then we have got a hour down, I'll put a hour on top, and then a second down. In 1 hour I've got 3,600 seconds. So the hour cancels with the hour, the kilometers cancels with the kilometers. 600 multiplied by 1,000 and then divided by 3,600. That will give us 166.67 meters per second. Now, since this plane is traveling at this velocity, even the parcel that it gets to release will be traveling at the same velocity. But remember, it is traveling horizontally, so there is no component in the y. There is no component of the velocity in the y. So we're going to find first the time it will take for it to hit the ground here. How do we get to do that? We know that height is equal to ut plus half gt squared. The height, that is 1960 meters above. Now there is no component in the y, so u is going to be 0 in the y because the plane is traveling horizontal, and then plus half. G is going to be positive because the parcel is dropping, and then t squared. So that will be 1960 being equal to 9.8 divided by 2, which is a 4.9 t squared. And then we'll divide both sides by 4.9. 1960 divided by 4.9, that is going to give us a 400. And then we'll square root now both sides. So that is going to give us 20. That will be 20 seconds. So that is the time that is going to take to hit the ground. So to find the distance AB, that is simply the range. Range is given by velocity in the x multiplied by the time of flight. and the velocity in the x is the same velocity at which the plane was moving. So that is 166.67 multiplied by 20, and that is going to give us 3,333.4 meters. So that is the distance AB that the passer is going to drop. A car traveling at a speed of 54 kilometers per hour is brought to rest in 90 seconds. Find the retardation. So the first thing is I'm going to convert that value to meters per second. Always work in SI units. So 54 kilometers per hour multiply in 1 kilometer. I'm putting a kilometer down because a kilometer is on top. We have got 1,000 meters, and then in 1 hour we have got 3,600 seconds. That will be 54 times 1,000, then divided by 3,600. That is going to give us 15 meters per second. So the retardation, we know the time, we know that v is equal to u plus at. This is linear motion. The final velocity, since it is brought to rest, the final velocity is going to be 0. The initial velocity, that is the same one, 15, and that will be plus acceleration a, which we don't know, and then the time in which it's brought to rest, that's 90. We'll take the 90a the other side, it will become negative 90a, and that will be equal to 15. So to find a is going to be 15 divided by negative 90. That will be negative 0.167 meters per second squared. The reason as to why it's negative is because it is deceleration. It is retarded. And then part 2. Want to find the distance traveled by the car before coming to rest. How do we find that? Know that 2as is given by v squared minus u squared. So that will be 2, the acceleration, negative 0.167, and then s, that will be equal to v squared, v is 0, minus u, the initial speed was 15, we get to square that. So s is going to be negative 15 squared divided by 2 multiplied by negative 0.167. And that is going to give us a distance of 675 meters. So that is the distance it travels before coming to rest. The speed limit along a certain road is 80 kilometers per hour. To stop at a junction, the driver applied excessive force on the brakes and skidded for 55 meters before stopping. The coefficient of kinetic friction between the tires and the road is 0.75. Determine if the driver exceeded the speed limit. Firstly, let's convert the 80 kilometers per hour given in SI units. Well, it's not even necessary to convert that. That will just help us to determine whether the speed limit was exceeded or not. That is the speed limit. So if we find the value of speed greater than that, then the speed limit was exceeded. Now, the thing that we know here is that this vehicle was moving. So the vehicle was moving. Now the driver got to apply brakes on this vehicle, so it is moving at a certain velocity v, but at the end the final velocity is going to be 0. Why? Because the driver has applied brakes to stop, but before getting to stop, this vehicle had to skid 55 meters. So there is a certain force which is applied, for it to skid, the brakes are on, and so there's no velocity there's no force which is being applied on the engine. The only force acting on this vehicle is the force in the opposite direction, that is friction, kinetic friction in this case, and we've been given the coefficient of kinetic friction. So the net force on this mass in the x is going to be given by forward force. There's no forward force, but there is a backward force. Forward force is 0 because the brakes are on, and then minus the backward force, that is kinetic friction, and the net force is given by mass times acceleration, and that will be equal to negative. Friction force is given by mu k times the normal force, and normal force in this case is mg, because normal force is going up, mg is coming down like that. Unless if it's on an incline, it would have been different, so the masses get to cancel out. So the acceleration here is going to be negative mu k, that is 0.75, and then g 9.8. Negative 0.75 multiplied by 9.8, that is going to give us negative 7.35 meters per second squared. So this is the acceleration or the deceleration of the car. So we can now use an equation of motion to be able to find how far it will go. I mean the velocity at which it will move before it gets to stop. So this will be 2, the acceleration already determined, negative 7.35, and then the distance it traveled, this is 55, and that will be equal to the final velocity is 0 because it goes to rest, minus the initial velocity which we are calling v, let me call it vi squared. So this will be 2 multiplied by negative 7.5 multiplied by 55, that is 808.5. Of course it's negative, and that will be equal to negative vi squared. So we'll get to divide both sides by that negative so that the answer is positive, and then we're going to square root to just remain with v initial, so that will be a square root of 808.5. So v initial is going to be equal to 28.43. This is going to be in meters per second. So to see if the speed limit was exceeded, let's convert this value to kilometers per hour. So velocity is 28.43 meters per second. So multiply. We have got a meter on top, we're going to bring a meter down and the kilometer on top. We know that in 1 kilometer we've got 1,000 meters. We've got a second down, we're going to take a second on top, and an hour down. In 1 hour we've got 3,600 seconds. So that is going to give us 28.43 multiplied by 3,600 and then divided by 1,000. That is going to give us 102.4 kilometers per hour. So compare 80 kilometers per hour with 102. So we get to find that the speed limit was exceeded for this journey. And well, that marks the end of this practice questions. Thank you so much for being present. Enjoy your day.